For 2.6 with the quadratic formula, I know it's going to sound like a broken record, but I just want to make sure it's said. Completing the square takes a lot of time. And the cool thing about it is, even though it takes a lot of time, every single time we're doing like the same thing, right? Like, we're never doing anything different. We're factoring out the leading coefficient. We're dividing b by 2. We're squaring it and doing the same thing over and over. Because we're doing the same thing over and over, maybe there's a generalized rule or a way that we could do this to get our answers without actually having to complete the square every single time. Now, turns out that the answer, or the way to do that, is through what's called the quadratic formula. There aren't a ton of times in math where we can see exactly where something happens. We're going to do a problem right up from the get-go that's our first kind of focus, where we are going to derive the quadratic formula. Now, the word derive, when we're looking at stuff, it just means to see where something comes from. As we go through this process, I want it to be very clear. We will do this once together. I do not necessarily expect that you guys, everybody in here anyway, could do this on your own. It is not the easiest problem that we've ever done. Here's the deal. We're going to do this by completing the square like we have been, and you guys are going to help guide us through. Now, if we make a mistake in here, and I'm going to try really hard to stop us from making a mistake, but if you think you're going to make a mistake, or if you don't understand something that happens, what should you do? Like, if we do something here and I write it down, whatever somebody suggests, and you're not sure what just happened, immediately, what is your responsibility? Yeah, ask. Raise your hand if you want to, but ask. Let's make sure that we're all cool with this. Now, here's the cool thing. Every single quadratic that we have solved in the last couple days with completing the square, we have all had the form, and we're just going to start with consider the following. We want something that looks like ax squared plus bx plus c, and we've been setting it equal to what? 0. If we're looking for the solutions, the roots, the x-intercepts, every time it is 0. Now, as we go through here, we're going to break this down into a few smaller steps so it feels more manageable. And we're going to go back and forth with how we change. First thing, this one's going to be really, really quick. We're just going to call this step 1. I want your guys' help to isolate the x terms on one side. Isolate the x terms, so anything with an x with it, on one side. Okay, so I'll give you guys just a second. This first step should go very quickly, but what I want you to do is, from this ax squared plus bx plus c equals 0, is I want you to isolate it on one side. And I'm just going to take a peek at a few of your pages. I just want to see what happened, because it's way easier than you think it's going to be. I want only things with x on the left, which means there's only one little thing that has to move. Yep, from that general equation, how do we make it so the only things with x are on one side? And if it wasn't immediately clear, like, I think it takes more time to just explain it than it does to do it. What's the only thing here that I need to move? C, right? So if I do this, do you guys agree it looks like this? Okay, nothing too crazy, right? I just subtracted c from each side of this equation. Only x is on the left, just like we've done with completing the square. Now, in this example, what is the leading coefficient? It's an a this time. And what do we want it to be? A 1. How do we make the leading coefficient 1? And that's what I would consider step 2. Make the leading coefficient, LC, equal to 1. Now, in case the language just gets you bogged down here, the leading coefficient, remember, it's just a number in front of x squared, the number in front of the biggest power of x. What is it right now? A. What should I divide everything by? I'm going to do that. I will divide everything by a. Yep, I want to make it a 1, but right now it's an a. To do that, we'll just say divide everything by a. And if you don't need to write this little annotation here, I'm cool with that. But if we divide every single piece of this by a, what does it leave behind? What's ax squared divided by a? X squared. Plus, what's bx divided by a? And I'm going to write it a little bit different. Can I write it as b over ax? Okay, equals negative c over what? A. Now, the whole point of this was just to get to our leading coefficient of 1. We did it on the problem from the homework that we went through with a 7. We factored the 7 out. It's the exact same step that's happening. It's just more generalized here. Okay, once we have a leading coefficient of 1 and we have something that looks like x squared plus something x, we need to add something to both sides of this equation. How do we decide what we're going to add? You take whatever this is just a number, right? It's ugly right now because it's b over a, but it's just a number. We take this coefficient and we divide it by what? 2, and then we do what to it? Now, anybody who doesn't love fractions, dividing by 2 can make this ugly, right? B divided by a divided by 2 sounds like it sucks. But here's the deal. Dividing by 2 is the same as multiplying by what? 1/2. So we're going to go ahead and call this step 3, and we're going to add something to both sides. Now, in yesterday's problems, we did it both in the same side. It was a 0, but it's the same thing as adding it to both sides instead of just subtracting it. So we're going to add the following. We're going to take b over a, and then instead of dividing by 2, that's the same as multiplying by what? One more time? 1/2. And then we do what to it? Square it to both sides. Okay. This is the ugliest part. I'm going to do a little bit of scratch work here, and we'll go back to this red color. If I take b over a, and I divide it by 2, which is the same as multiplying it by 1/2, and I square it, let's deal with this just step by step. On the inside, what do I have? B over, is it just a? 2a, and then it gets what? Squared, which one more little scratch work here. How do I square a fraction? So I square the top, it's b squared over, what's the bottom? So careful, it's 2a times 2a, right? 4a squared. Now, the process, I just want to stress, it's the exact same thing that we've done yesterday. Anytime we were completing the square, it's just ugly with this general form. Everybody, let me rephrase, is anybody not okay with this part? We divided it by 2, but we just multiplied it by 1/2 because it's easier to do the math. Okay, so we'll add that to both sides, which means on the left side, I now have x squared plus b over a x plus b squared over 4a squared equals, and looking at this one, it's going to be weird, but I'm going to write this first. B squared over 4a squared minus c over a still. This was the thing that I added to both sides just now. So far, questions, issues, anywhere that we're not quite sure what has happened? Okay, if I were to ask you guys to do this again, everybody could do it perfectly then, right? So we'll retry it one more time. Any questions? Can you follow everything that's happening? Whether you could do it or not on your own, different question. All right, hit it. So instead of, I elected to write it like this because if I wrote b over a over 2, it's gross, right? And anytime that you have a fraction connected to this x, what I would always advise is instead of thinking about it dividing by 2, let's think about it as multiplication because it's the same thing. Multiplying by 1/2 is easy. Dividing by 2 is less easy. Okay. I'm sorry? Why do I add it to both sides? Because if are you cool with why I added it here? Yep. It's just whatever I add to the left, I have to add to the right as well. It's that property of equality. Okay. Now, 2 steps are going to happen on this one. And we're in step 4, I suppose. Looking at this, we're going to do 2 things. I want to factor and I just want to look at this real quick. Is the left side nice right now? What's this process of leading coefficient 1 and adding this? That was to make this a what? Let's factor the perfect square trinomial on left side. But we're going to do another thing. And common denominator on the right. Now, we're not factoring the common denominator, but we are just going to rewrite it. So the good news is that this doesn't have to be awful. If we take the square root of x squared, do we know what that one is? It's x. What's the sign on that middle term? Plus. And two ways you can think about this. If I want to know what the square root of this thing is, and it's kind of ugly, but notice we just took this and squared it, right? This is the square root by definition. This squared gives me this, means that this is the square root, like it goes both directions. Now, even if you don't recognize that, we can just think about the square root easily enough. What's the square root of b squared? What's the square root of 4? So 4a squared is 2a, but just 2 and a, right? So I can already see that this is b over 2a right here. And it gets squared equals, and we're going to clean this up. Is there a common denominator that exists on the left side or on the right side? So I'll catch up to us, and I'm going to do a little bit of scratch work right here. So we'll change color. If I want a common denominator, what is the common denominator for the right side going to be? So 1 over a is not quite common. Which one's uglier, the 4a squared or the a? I think 4a squared. I can't really break this one down any further to make it smaller, but is there any clever choice of 1 that I can multiply by to make this a 4a squared? It has 1a. What else does it need? It needs a 4. That would just give me 4a. There's one more little piece. A. If I multiply by 4a over 4a as my clever choice of 1, this is going to be minus, and let's just clean this up. I'm going to call this 4ac, because c times 4 times a, I'm just rearranging it, over what's in the denominator? Just right here, we do a times 4 times a. 4a squared. All of that just now in this pink little step was to give us a common denominator, and it just happened to be 4a squared. It's an ugly problem, but I promise the end is like we're pretty much there. We have 2 more steps. When we move to the next step, if we have a common denominator, can I just put them together? Like if I have 1/2 plus 2/2, that's just 3/2, right? I have a common denominator. I'm just going to shove this as one fraction on my next line. Okay, so we will now, last little step, without breaking it down a million more times, let's just solve. Now, in my notes in front of me that I have that I'm using and I'm not really using them, I have like 2 steps. It says complete the square and then solve. We're just breaking it down a little bit more. Hopefully it's helpful. Okay, if I want to solve for x, right now it's stuck inside of a square. But Kyle's going to tell me that to undo a square, we do what? Good. I'm going to take the square root of each side. And if you want specifics, I'll say solve for x using the square root property. Square root property. So I'll do the left side. It leaves me with x plus b over 2a. X plus b over 2a. And on this right side, before I write it, it's hard to see, but these are all just numbers, right? These are the numbers in front of the x's, which means if I'm going to take the square root of a number, what better go in front of it? Plus or minus. Now, there's not many times, like I'm really not a huge fan of this, but I do want everybody to engage, and I know you might think it's lame, but what always goes in front of a square root if you're taking it for a number? So that was like 30%. We're going to try again. What always goes in front of the square root of a number? One more try. Everything gets a what in front of it if you add a square root? There, that was much better. Cool. Sweet. So plus or minus the square root, and we're going to write this as a single fraction now since we have a common denominator. What's up top? B squared minus 4ac. So that's my numerator. And all of that gets still in the radical divided by, what's the denominator? 4a squared. Now, we're going to take little steps. Somebody, oh, hold on. Question. Are you sure? 100% sure? Okay. I don't know if I believe you, but if you're not going to ask. Okay. We're going to do 2 more steps here, and we're going to take little baby steps. Not baby, that sounds demeaning. We're going to take little steps. Okay. First thing that I want to do is I want to clean this up a little bit. I'm not going to touch the left side of this equation yet. If you are at your desk working, and maybe we could do this. I lied. I want to try something. I want you guys, I'm going to pause here. I'll come back to this in just a moment if I need to. I want you guys to finish solving this for x for me. Rearrange, solve for x. I'll come around and help as needed. I will have the work up on the board here in just a moment after you guys have had a chance, but I want you from this expression, solve for x. Cool. I'll give you a couple of minutes. I'm going to come around, ask questions when I walk by. Don't just look busy so that I don't ask questions of you. Cool. I'll be walking around for a moment and we'll come back together in, I don't know, 60 to 90 seconds. When we see this, there are easier things than you think. The numerator is kind of gross, and there's no nice square root property if we have addition or subtraction between them. Okay, I'm not going to touch the numerator because it's not a convenient thing to change. Do you guys agree that this is still, we could write this as just the square root of b squared minus 4ac? Now, I know that the square root of a fraction is the, do you guys remember the other half of this? The square root of a fraction is just the fraction of the square roots. So a lot of people had done this, but I think that everybody will be able to, whether you realized it initially or not. I don't know the square root of here. Bummer. Do you know the square root of the denominator? What's the square root of 4? And what's the square root of a squared? A. Now, on this line, the end is like right here. I can see it at this point in time. Why do I love seeing a 2a right here? I'm going to subtract b over 2a on my next line, right, to solve for x, and I already have a common denominator. Now, I'll do this in 2 lines. We'll go here, x equals, and I'll just go ahead and move that, subtract from each side, negative b over 2a, plus or minus the square root of b squared minus 4ac, and it's still all over what? 2a. As soon as I see this, if they both have the same denominator, can I just shove them together? Okay, so last line, and I'm going to go ahead and put a big star, 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 because this is incredibly valuable and pretty important, especially if you struggle with factoring. So check it out. I think I can write this whole thing as negative b plus or minus the square root of b squared minus 4ac all over 2a. First immediate follow-up. Does this look familiar to you guys? Okay, second thing, memorizing stuff. When I have this memorized, and you guys will, I promise you will memorize this. Everybody know the song Pop Goes the Weasel? Okay, can we all hum it? Ba-dum, 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 bum. Everybody know that song? Ba-dum, ba-dum, ba-da-da-dum, bum, bum, ba-da-da. Okay, so some of you recognize it, some of you don't. Are you guys good at memorizing a whole bunch of math stuff? How many of you know all the words to multiple songs? I don't know what, I don't believe you, first of all. If you're a human and you listen to music and you sing at all, you probably have multiple songs memorized. Okay, there's something weird about humans where songs make us remember stuff, and I don't know why. I make my calc kids sing goofy songs to remember some special rules in calculus. This thing, turns out it fits really nicely to the tune of Pop Goes the Weasel. Tomorrow, bring your vocal cords, we'll be singing together. We're going to have a choir class in the morning. Like, not kidding, just so you know, like 100%. We're all going to do a little singing tomorrow. In key, out of key, don't care. Cool. All right, now, here's the deal. What did we just do? So, what? I misheard you, I think. Not what I heard. Okay, so we did. But realistically, this whole process, Like you can look in your notes and it says derive the quadratic formula. Cool. What's the significance of what we've just done? When we solve for x equals by completing the square, what do we use that to solve for? We find there's 4 words that we could look for. The solutions, the roots, the zeros, or the x-intercepts. Now, this entire chapter has been focused pretty much around that entire idea. We went through all of the factoring stuff, and the value in factoring is that we use it to find the roots, the solutions, the x-intercepts, the zeros. Now, factoring can be hard sometimes. Now, for some of you, it might be hard all the time, but here is the awesome part. If all we are using factoring for is to solve, we now have a general equation that as long as you know A and B and C, you can now get the x-intercepts or the zeros, the roots, in this lovely plug and chug formula. Now, we are not going to have homework tonight. Tomorrow, we will sing this, like legitimately, but we want to make sure, last thing in our notes before we close them, is I want to make sure that we have truly what just happened. So, last little piece. I know it's redundant and we're just writing it again, but our topic or our last little statement in our notes is going to be the quadratic formula. Okay. This is arguably, I was going to say the most important thing we've seen, but really everything that we see is important in regards to math. So the quadratic formula, what we've just found is it, and I want to make sure what we all agree what this really means. Given a function, and I'm just going to say f of x, and it could be y, but if you give me any quadratic in this form, ax squared plus bx plus c, which is pretty standard form to be given for a quadratic. If you are given any of this function, the roots, the zeros, whatever you want to put here, roots, zeros, solutions, x-intercepts of f of x are at, and here it is, x equals negative b plus or minus the square root. Oh, I'm off. I got to work on this tonight. It's the reason I didn't do it today. I promise it fits. I just got to look to make sure. If anybody has a different song for this, I'm cool with it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Cool. Every single time. We will discuss and use this more tomorrow. Thank you guys for your work today. No homework.